Let's read this question. If the speed of the car is halved, how does its kinetic energy changes? So we have a relation kinetic energy is half mv square. So now we are making this half. So how it will be related to the kinetic energy? With this relation, square of the relation. And because it is 1 by 2, it will become 1/4. So this is the answer. Let's go next question. Two bodies of equal masses are moving with uniform velocity v and 2v. So the two second body has double the velocity. Find the ratio of their kinetic energy. So kinetic energy will fall in the relation of the square of it. What we can say 1:4. So intuitively we can do, and if you want to do mathematically, we can say K1. The body 1 is half m1 v1 square, K2 half m2 v2 square, but v2 has become the second velocity is double of the first one. V2 is 2v1, and we are assuming that they are equal masses. Here it is given equal masses. So if we make the ratio k1 divided by k2, half m will cancel out. V1 square will cancel out, but this 2 has to be squared, so it will become 1/4, or k1 by k2 will be equal to 1:4. But we can directly get it from the formula according to the changes we are making. Let's do the next question. This is also again very simple question. A car is running at the speed of 15 km per hour, while another similar car is moving at the speed of 30 km per hour. Find the ratio of their kinetic energy. So what is happening to the speed? It is getting doubled. So if it is getting doubled, what is the formula? Half mv square is the formula for kinetic energy. So we are doubling this. How the kinetic energy will get affected? So if v become 2v, this will become 2 4k, because the velocity will get squared. So kinetic energy has a relation with the velocity with the square of it. So if we are doubling the velocity, the kinetic energy will become 4 times. That's why the answer is 1:4. Let's go next question. A ball of mass half a kg slows down from a speed of 5 meter per second to 3 meter per second. Calculate the change in kinetic energy of the ball. So we can just change in kinetic energy. We can denote by delta Ke. Delta means final minus initial. So whatever it is in front, the delta shows that the it is a change, final kinetic energy minus initial kinetic energy. So we'll just calculate that. Here you can take, because the mass is same, mass is not changing, m2 and m1 is same. See, here it is written. So we can take half m common. Okay, instead of multiplying this as separately, we can take half m common here, and we just end up getting subtracting the squares. So the final, remember, it is 3. So 3 square minus 5 square, and we will get the answer of -4 joule. What minus tells? The change is negative. What does that mean? That means the energy has been decreased. And that was obvious from the speeds given. So the speed has become 5 to 3, so it has been reduced. So the kinetic energy will also change into the lesser one. So that's why we are getting the negative sign here. Let's go next. Question number 15. A cannonball of 500 gram is fired with the speed of this. So mass is given and the speed is given. Finds its kinetic energy and its momentum. Momentum is just multiply, just convert this into kilogram first and then multiply with the speed mv. That is the formula for momentum. And what about kinetic energy? Kinetic energy, we know the momentum, we can calculate easily. There is a relation. We should remember K is half p square divided by m, or p square by 2m. So put the value which you have calculated of momentum here. You can able to calculate the kinetic energy also. Let's do the next question. A bullet of mass 50 gram is moving with a velocity of 500 meter per second. It penetrates 10 centimeter into a steel target and comes to rest. Okay, calculate the kinetic energy possessed by the bullet. First thing is kinetic energy we need to calculate, convert this into kg first, and then use the formula half mv square. We will end up getting 6250 joule, or 6250 joules. So this was the energy the bullet was coming with. So this was the kinetic energy it was having. So when it will enter this fixed target, this square box I have created to show the fixed target. So when it will enter here, what will happen that this target will give a opposite force, because it is going to penetrate and it will work on that, and it will consume whatever the kinetic energy it was having. It will start working on the bullet. So the force given will be in this direction, opposing force, right? So there will be negative work done so that we can take energy out of this bullet. So 10 centimeter has gone. So we know the distance is this much, or zero point 0.1 meter. So what will be the force it is giving? So that is what it has been asked in the second part, the average retarding force offered by the target. So the average retarding force will be equal to work done. So we can read it here. The force during input is not constant. When bullet enters the target, it experiences a very large force at first and then gradually smaller forces as it slows down and finally comes zero when it stops. Since the resisting retarding force varies during penetration, we replace it with average constant force. So that is why in question they are asking average retarding force. When the bullet will enter at the start, the force will be huge, but as it slows down, the speed will become lesser and lesser, and the force will also become lesser to oppose that. But this average word they have used because they want to see, just imagine that is a constant force during this displacement. So how we can do it? Displacement we know is zero point 0.1 meter. We need to calculate the force which will be acting to this. What is the objective of this work done? That to consume the kinetic energy which we are having. We can use here the kinetic energy theorem, and that is work done will be equal to change in kinetic energy. So final kinetic energy, it will become at rest. So I put it kinetic final as a 0, and the initial kinetic energy is 6250. So because they are in the opposite direction, we are getting the -1 sign. Because a target will push the bullet like this. It will offer the friction in this direction. That's why the displacement and the direction of force is 180 degree. That's why we will get cos 180 is equal to -1. Now we need to just solve for it, and we will get the force as 62,500 Newton. So this is the average retarding force offered by the target. Okay, let's do the next question. A body of mass 10 kg is moving with the velocity 20 meter per second. If the mass of the body is doubled and this velocity is halved, find the ratio of the initial kinetic energy to the final kinetic energy. Remember the sequence which they are giving, the same comparison we need to do. So we have to find Ki divided by Kf. Now just put down their formulas. This will be half. Mass initial was, let's say, m, and the velocity was 20. Let's say initially it was v1, and now we have to divide it by m2. So this is a general expression, and v2 square. Now what is the relation? What they are saying, that mass of the body is doubled. So this became double of this. So this will cancel out and only 2 will be remaining here. So m2 will be 2m1. So it will cancel out. What about the velocity? The velocity is half. So this will become 1 by 2 of this. V1 square will cut, but 1 by 2 square will go up. So 4 will get here. So the relation 2 2s are 4, half and a half will cut. So the relation will become as 2:1. So this we can do. You can do it by yourself step by step. Okay, let's do the next question. A truck weighing 1000 kilogram force changes its speed from 36 to 72. It is doubling its speed actually in 2 minutes. The work done by the engine we need to calculate, and its power. We have to take G as 10. So here the speed change is given. So we can easily calculate the change in kinetic energy. And from there we can derive the relation, use the kinetic energy theorem for the work done which is being asked here. So that is what we will do. Work done is change in kinetic energy, Kf minus K initial. We will put this. I'm taking half m outside because mass is constant. So we'll end up just subtracting the squares of final and initial velocities, and we'll get a value like this. So work done by the engine is 1.5 into 10 to the power 5 joules. Now work done, this work done was done in 2 minutes, or 2 into 60, 120 seconds. For the power, we take per second. So we have to divide the work done, total work done is this, divided by 120, and we will get 1250 watt. So that will be our answer. Let's go next. This is also very simple question. A body of mass 61 kg has the momentum of 3000 kg meter per second. We need to calculate the kinetic energy and the speed of the body. Second, the speed of the body. So we know the momentum is given to us, so we can put this relation: kinetic energy is equal to half p square by m. We can put the momentum here and the mass here, and we can easily calculate the kinetic energy. And after that, to calculate the speed of body, just need to do half mv square, and we can calculate v also from there. So you can do it by yourself. Let's do the question number 20. How much work is needed to be done on a ball of mass of 50 gram to give it a momentum of 500 grams centimeter per second? So first what I did is I just converted them into SI units, kg, and gram centimeter per second. I changed it to kilogram meter per second. So if you want to see how I have converted, so 500, forget it, but gram we have to put kilo here, right? Kilogram it should be there, so I have to write 10 raised to power minus 3. Then centimeter, because we don't want it, we just want meter, we have to put 10 raised to power minus 2 here. And then it will come as 5 into 10 to the power minus 3 kilogram meter per second. So this conversion, this question is asking, you should be good at it. Now, what they're asking is um, how much work is done. So we don't have any direct relation with the work done, but we have momentum and kinetic energy relation. Okay, so that is what we can do. So work done is change in kinetic energy. Okay, if final initial kinetic energy, if we assume it was 0, then it will just equal to half mv square. And v we know is p by m. So p is momentum here. So we can put half p square by m. So we are using the relation of kinetic energy is equal to this one, and change of that is equal to work done. So if we solve it, we will get it 2.5 into 10 to the power minus 4 joules. So this much of work is to be done. Let's see the next question. How much energy is gained by a box of mass 20 kg when a man carrying the box waits for 5 minutes for a bus? So there is no energy, because there is no, we are not moving it first thing, and we are not even raising it. If the box is just stationary here, so there is no height exchange, there is no height change, so no potential energy increase, there is no speed also because he's standing. So the energy gained is 0. What is the second part? Runs carrying the box with a speed of 3 meter per second to catch the bus. So when he's running, of course, now he's running with the speed of this, so the box will also have the same speed. So we can calculate the speed as with the formula of half mv square, and the answer will be 90 joules. Now what is asking, third step is raises the box by 0.5 meter. So when he makes the vertical displacements, he will uh, give it the potential energy, which we can calculate by mg delta h. So this is mass of the box. Here goes the g value 10, acceleration due to gravity, and this is the height which he puts box on. So 100 joules of potential energy is given. Let's do this question now. A spring is kept compressed by a small trolley of mass half kg lying on a smooth horizontal surface. Smooth means here that no friction. There is no friction there. When the trolley is released, it is found to move at the speed of 2 meter per second. What potential energy did the spring possess when compressed? So actually what happened, it was like this. And now when it got released, it got some kinetic energy. Now the question is from where this kinetic energy is coming. Of course, it is coming from the potential energy of the spring. It was compressed, it released its potential energy into this box, and the same energy is gone and converted into kinetic energy. So if we are able to calculate the kinetic energy here, we know what was the potential energy string processed when it was compressed. So we will just use the half mv square formula, and that will be of 1 joule. So the same energy will be of the spring, that is 1 joule.